They be laughing.
Possible. Rational. What's rational mean? What kind of a number is a rational number? Not an irrational number, but a rational number. What is that? Come on, guys. You know this.
A rational is just a...
It's anything that can be expressed as the ratio of two numbers, a fraction or a decimal or anything. All right. Possible rational zeros. So we've talked a lot. If I give you a polynomial and I give you a zero for that polynomial, then you can take that information and you can find another factor for that polynomial and then factor completely from there. Or you can find all the other zeros given just that one zero. But now we want to talk about, what if I give you nothing and I just give you this big long polynomial? What can you do? So what we're going to do is we're going to make a list of possibilities, a list of numbers that may or may not be a zero. Then we're going to test those numbers and see which one really is a zero so that we can finish factoring and finding the other zeros. Okay? So the first thing you need to know is, where does this list of possible numbers come from? Right? Are you curious? Let's say I gave you 2x cubed plus 3x squared minus 11x minus 6. Okay. Possible rational zeros, or PRZs as I like to call them, come from a combination of the leading coefficient. Now what's the leading coefficient here? 2. And the constant, what's the constant? 6, right? If you list out all the factors of each one of those. So let's look at 2 first. What are all the factors of 2? Huh? 2 and 1. I'm going to throw a little plus or minus in here because do you agree that -1 times -2 would give you positive 2? Okay. How about 6? What are all the factors of 6? Constant. This is the constant. I'm fixing to show you why. All right, so somebody said 1, 2, and 3, and 6. The PRZs are every combination you can make using the factors of the constant divided by the factors of the leading coefficient. And here's my leading coefficient. Wow. So, looking at my example here, for this particular polynomial, what would be the PRZs? What are all the possibilities that I could list for this?
1, 2.
All right, let's do it with the plus or minuses. All right, hold on. Understand what this is that it's telling you. Here's my factors of the constant. These are always going to be the numerator. These are always going to be the denominator. Okay. So if I took all these and divided them by 1 first, I would get plus or minus 1, 2, 3, and 6. Does that confuse anybody? Because anything divided by 1 is itself, right? Does that make sense? But then I have another factor here of 2. So that means I take these same ones now and divide each one by 2. 1 divided by 2. What's 2 divided by 2? 1, that's already in my list. 3 divided by 2. And then 6 divided by 2 is, and it's already there. So these are my PRZs. You take all these numbers and you first divide them by 1. So that's how I got these. Then you take all these numbers and you divide them by 2. You don't have to repeat things, which is why I did
it in a different way. Like you first just divide all of them by 2 and then divide by 1.
Sure. So you could say 1/2, 1, 3 halves, and 3, and then you could come back and divide everything by 1. Does that make sense to everybody?
Why?
That's how you do the problem.
These are not the actual zeros. These are not places they cross. These are possibilities. They may or may not be a 0.
1 divided by 1, 1 divided by 3. Or is it that you, the constant?
You following?
And then divide by 1.
Tracking with me? Okay. Let's look at another one and see if you can do it, because this is really the only new stuff, but it's just we're going to have to apply everything we've learned. Let's say my polynomial was 3x to the 5th minus 6x cubed plus 2x minus 4.
Have to do the yeah.
No, not right now. Eventually you will, but when you're finding PRZs, no.
Oh.
PRZs only deal with the constant and the leading coefficient. Well, or we can do it together. You can try real quick. I'm going to just list the factors under here. If you know the factors, you don't have to list them. It helps me to see them. Right? So now I need to make every possible fraction dividing the constant by the leading coefficient. Right? Looking confused.
So what?
So if you want to do it like this, 1 divided by 1, 1 divided by 3. 2 divided by 1, 2 divided by 3. 4 divided by 1, 4 divided by 3.
Oh, that's all it is?
You can do it that way. I just like to do them, divide everything by 1 and then divide everything by 3. Excuse me, the order's not that important. It's just that you come back with the same possibilities. 1/3, 2/3, 4/3. So there'll be a question on your test that says, what are the possible rational zeros? That's not asking you to find all zeros. All you're finding are the possibilities. One may or may not be a 0, but it's a starting point for us. Now, while you're writing that, I want you to think about something with me for just a minute. How could I test to see if something was or was not an actual 0? Okay, so I heard plug it in. What would? Because what happens when you divide by a 0?
It's 0.
What's 0?
The answer.
Keep throwing math words out there. We're going to get there eventually. Think about what happens when you divide something by a 0. The remainder is 0, right? Because the 0 is part of the factor, and when you divide by a factor, you get 0. So if I can find one of these that when I divide, it gives me 0 remainder, then I have found a 0, and in turn, I have found a starting point that I could maybe finish factoring this. Okay? All right, so when we PRZ, and I'm going to give you a couple little steps, and then we're going to use them to work through an example. So when we PRZ, I'm using a lot of quotes here for some reason. We test zeros by synthetic division.
Synthetic.
And what we're looking for is a remainder of 0 so that we can finish factoring. And I'll give you a second to copy those. I'll pause. Okay. All right, so let me tell you what I'm talking about. Let me show you what I'm talking
I
about.
know you're about to do a Zapparano.
Yes. So you'll start with, and I'm going to get one that's going to work out nicely because make it up off the top of my head, it's going to be zeros everywhere. You're given a polynomial. And all the directions for this say, let's find all the zeros. Uh-oh.
X to the third minus 8x to the second.
I hope that at this point you know that finding a zero means we set the equation equal to 0 and we solve, right?
Yeah.
So if I set this equal to 0 and solve, the only way that I know to solve might be to group it. Yes? Can I group that?
No.
No. So I've hit a brick wall. Do we agree?
Yeah.
Okay. So if they gave me a 0 to start with, I could go from there, right? Because that's what you did last night. Given a 0, find the rest of the zeros. But they didn't. So what I'm going to have to do is list out my possibilities and start testing them. So let's do that first. What are the possible zeros? So what are my PRZs here? And this is easy because the leading coefficient's 1, but go ahead. 1. Let's go in order.
2,
2,
4,
4.
5, 10, 20.
Is anyone confused about where that list of numbers came from? Okay. So, here comes the tedious part. Are you ready? Let's
Wait,
start
you gave us 2
testing.
seconds.
Yeah. 2. Okay. No, I'm just kidding. Ha!
Also go there?
Say again.
Would 11 also go in there?
It's only factors of 20. And then divided by factors of the leading coefficient, which is 1. All right. Let's start testing. I need to find out which one of the possible zeros are an actual 0. Well, the only way I know to do that is divide. And whenever I get a remainder of 0, I hit the jackpot.
That's all you're gonna do?
So let's start with 1. Okay, you wish. Just, I was going to say, what do you mean is that all we have to do? There are 1, 2, 3, 4, 5, 6, 12 possibilities listed here. And I have to keep trying them until I find the one that works. What do you mean is that all?
You're freaking kidding me.
Wait, so where'd you get the 1?
All right, I'm just starting with 1 here. I'm working my way down the list. Yes, the more PRZs you have, hopefully it's going to be one of the first few that you try. You see why I told you would really want to be a pro with synthetic division? Imagine if you were doing long division on all of these. Holy cow. Be here all day.
Miss McGee, I know we're not gonna have that on the test.
This is my favorite problem. You know why this is my favorite problem?
It's not that it's hard, it's just a lot of...
It is, but it allows me to test you to see if you can synthetically divide, if you understand the concept of a 0, if you can factor completely, if you can factor and solve. It literally encompasses everything from chapter 2 so far.
That's
Miss
crazy.
McGee,
And part of
everybody know how to
chapter
do synthetic division. Excuse me.
All right, -7, and that's 3, that's 3, that's 20. That does not work because this remainder is not 0.
Oh,
On to the next one, -1.
you're gonna be doing 30.
It's actually 4, by the way.
I'm not even doing it.
Is it 4?
Yes.
The third one up there. It's
Wait,
4.
how do you figure that out?
11 minus 7 is 4.
Ah,
Wait, so you don't have 6, you actually have 12.
that's correct. That's why I said you got 12 possibilities. Thank you.
Chill.
Oh, look, I found one.
How do you know which one, where you get the
When you
remainder?
get a remainder of 0, stop. Because you found one. And I only need, hopefully, you'll get to some double PRZs soon. Right now, hopefully, I only need 1 real 0 to finish solving the problem. So now understand what this means. Now this is transformed from a find all zeros problem to a find all zeros given 1 0. Right?
So we're going to put that back into the equation.
So this means
Oh, okay.
x plus 1 times x squared minus 9x plus 20 Equals 0. Because to find zeros, I set it equal to 0 and I solve it. Well, now the question is, can I break this down any further, or can I set it equal to 0 and solve it by the methods I know how to do?
Yes.
Yes, I can factor it. Thank the Lord I can factor it, because that saves me a whole lot of grief, right? Seeing as how there's no leading coefficient, it's a very easy factor, same signs. What multiplies to 20 but adds to 9?
4 and 5.
4 and 5.
Mickey, I'm really.
Okay, where are you confused?
If it's a factor, shouldn't it go into it without a remainder?
Right, that's why, here's the 0.
But shouldn't all of them?
They're possible zeros. So we test them to find which one is actually a 0. It gives us some numbers to start with, so we don't just randomly start putting in numbers. Wouldn't it what? Ask me again.
This not even hard. It's too much work.
Oh my goodness, that ain't a lot of work. Look at that page.
I'm talking about trying to put in all them things.
That's because you're lucky.
We were
Yeah,
lucky.
We was lucky. Like, that's gonna take 30 minutes a problem.
If you're good with your graphing calculator,
What if you have them?
huh?
What did you don't
If you have one, you might want to get one. By the way, a lot of you have asked me, when will we get to that point where we will rely solely on the graphing calculator? That will come tomorrow and Monday.
What can I do
I
with my
bet.
graphing calculator that
Alright.
can speed this up?
Graph it. So
What
hit
about-
y equals and graph it. And if you look at where the function is
Where
crossing
x
the
plus one and then the x
x-axis,
squared stuff?
huh?
The x plus 1 and the x
Yeah.
squared?
No, the original equation.
Then you look like him.
Is that it? Is that what we have to do?
This one's solved because I have the 3 zeros. Now, but there's a couple, hold on, and I'll show you in Desmos if you don't have a calculator. I don't want you to
I have
try.
a question. Is that all we have to do?
Yes, for this one. So look, a couple of different scenarios could arise, and I want to make sure I talk to you about.
What is, what?
When you get to this point, this x squared minus 9x plus 20. If it doesn't factor, what will you have to do?
Quadratic formula.
Understand
Can we
that's a
complete the square?
possibility. Complete the square, absolutely. Good job, Shami. Now look, here's the thing too. What if I had taken this out and this was x to the third minus 9x squared plus 20x plus 5, and it didn't group?
You talking about with the split thing?
If I couldn't break it down, I may have to do PRZs on this piece again. And keep going through that process. So let me show you quickly. If you do not have a graphing calculator, and if Dean and the people at the district can get Dino running, I'm okay with you using this on your test.
Using what?
But until we can make sure everything else is blocked, I can't let you use it. If you go to Desmos, no, did you hear what I just said?
I was gonna be all over.
You are the reason we can't do that.
I was playing. You can see it was on.
All right. If you go to Desmos.com, it's an online graphing calculator. And I really want to show you. Somebody who still has that equation, give it to me. X to the third. Hold on. I can't find my caret on here. Thank you. Oh no. All right, x to the third. X squared plus 11x. Thank you. Plus 20. So this is a very interactive tool. It's really good. You can zoom in and out on it, but it is a graphing calculator on the computer. It's a little more user-friendly than is your graphing calculator. Of course, when you get on PSAT, SAT, all your standardized tests, you can have your device, so it's a good thing to learn on your calculator, but some of us have struggled to get a calculator, so until we do, this is a good option for your homework and stuff at least. But if you look, this is, I just typed in the equation that we graphed, and I can literally touch the point that I want to find. And it should tell me the coordinates whenever I hover over it. So do you see it telling me -1? Well, that would be very useful when I'm here to know one of the zeros is -1. Right?
No.
Now, am I going to make you show all your work?
No.
Absolutely. But I'm telling you, what if that 0 was all the way up at 5 and you had tried 1, -1, 2, -2, 4, -4, and you got all the way to 5? If you knew 5 was a good starting point to start with dividing, it would cut out a lot of work for you, right? It's kind of a little cheat. So here, if I saw this equation, I would probably go in and say one of these two is what I would divide by first to start with and kind of go from there. Does that make sense?
Yeah.
Because what I'm finding are zeros. And my emulator, I have a TI emulator for my computer, but it's on a CD, and I don't have a CD drive for this, so I can't install it on here. I'll have to get Dean to help me with it. Or else I would show you on your graphing calculator, but I'll show you that tomorrow whenever we get into that. I'll get that fixed today. All right, let's do another one because this is all it is today. Yeah.
Monday you gonna show us the shortcut of this, right?
This is the shortcut.
Oh my. Well, how you deal with?
Let's try a hard one.
Shortcut. It's significant.
Shami, everything doesn't have a shortcut. 2x to the 4th. Oh my goodness, such whiners. Well, Tanner's such a whiner. 5x cubed minus. Oh, that sounded like an exasperated grunt. Minus 19x plus 42.
King John II.
By the way, we've mentioned this several times in here. How many zeros do you think this one is going to have?
4.
4. That, by the way, is the fundamental theorem of algebra.
Minus
42 is such a big number.
Second minus 19x plus 42. Oh. You got a fry.
I told you I was going to do a hard one together.
Our homework.
No.
Is your homework this hard? Not all of it.
How many questions we got? Like 3? We got like 3
one
questions?
that's not hard? The rest are like this?
No. They're not. This is, if I'm not mistaken, I have this one starred in my book, and I think, I didn't do the one that I have written in big bold letters in my book that says never use this as a first example. We didn't go over that one. This one, I think, is a double PRZ in quadratic formula, if I'm not mistaken.
Are you trying?
I love it! I don't... all the factors of 42, and then all the factors of 42 divided by 2. There's a lot. You want me to list out the PRZs for you
We
first?
gotta start over because Grant wasn't in here this week. Oh, he probably already know how to do it.
We were laughing about that yesterday, Shanique. Miss Wilson came in and I said, we were playing Kahoot, and I said, Shanique had a fit because Grant got one wrong, and he said that the world was just over or something because Grant had gotten one wrong.
He had 100 in French. How do you do that?
Did you really? I have 2 zeros in there.
I had like an 88. I ain't doing something like that.
All right, are you working? 6, 7, what else goes in? 14?
I had the number.
1, 2, 3, 6.
21's the next one.
21 and 42.
Yeah, but now I have to divide everything by 2. Moly. 3 halves. Grant, you might be really lost for just a second, but I think you'll pick up real quick what we're doing. Right now we're just listing out possible zeros. They may or may not be a 0, and then we're going to test them. The top number is every combination of factors of the constant divided by factors of the leading coefficient.
It's being good.
So factors of the leading coefficient would be 2 and 1. So I divide every factor of this by 1, then divide every factor of this by 2. And then we're going to test them. All right, y'all got it? It's not a hard concept. It's just, it's very cumulative. It puts all our steps together.
Oh, why we divide everything by 2?
Factors of the constant divided by factors of the leading coefficient. Your leading coefficient is 2. So factors of 2 are 1 and 2. So we divide everything by 1, then we divide everything by 2.
Oh, yeah, I forgot about that.
Yes. What? Is your head hurting? Hold on, let me.
I was scorched.
Not just fried, scorched. Has anybody found a good zero
Are we
yet?
supposed to be doing it?
I just finished.
Yeah!
I was just sitting here. On this sheet.
I haven't taken it up yet. We did things a little backwards.
Wait, I'm trying 6.
Okay, somebody said they're trying 6. You want me to give you a hint?
Yes.
Start trying the fractions. Ah!
I mean, this literally.
Look, if I saw this, the very first thing I would do would be to type this in my calculator.
Okay, well, mine's dead.
Okay, well, open up your tablet and do on Desmos.
Okay, that one's dead too.
Goodness, Tanner, don't you charge anything at your house?
Oh, mine dead. I mean, no. Mine don't connect to the internet. I don't know what's wrong with mine.
Shami.
I'm so serious.
I'm going to go ahead and type this in Desmos and see what happens.
Okay, I need to
Desmos.
watch you do that.
All right, so if you go to desmos.com. I'm sorry. It's on the board right here.
Oh, no.
Oh, the zeros. Okay, hold on. X to the 4th
That's fun. Is it over?
minus 5x to the 3rd.
That's not. Look at how mine looks.
It's pretty.
It is pretty. Sophia, she typed this calculus equation into her
Ooh.
calculator, and it
I
created
try
like
1/2.
really tiny ones.
I mean, 1/2.
Did I type that equation? Oh, it's 2. Wait, I typed the equation. It's 2. Okay.
Oh, wow.
Never mind.
2x to the 4th. Oh, it's plus. Oh my goodness. Get it together, Stacy.
Yep, that's how it's.
Oh, there's a good one to try. That's the way I would approach this problem. Because if I had started trying those numbers, I would be way down the list before I found one that worked. Okay? So if I'm working this, I don't even call it cheating because it's a calculator and you can use your calculator.
Do you have one of the you said you had a calculator thing?
I have an emulator, yes.
Can you pull that up? There's another one.
It's not, I can't get it loaded on this computer because it's on a CD and this doesn't have a CD
There's another
drive.
trick you can do
What?
with y equals. If you put in the equation and then what's the function on it that shows you the table?
Second graph.
Yes. If you go second and then hit graph, you can just go through and find all of
The zeros? Yeah,
ones.
yeah. And we're actually going to calculate them starting tomorrow, like with the calculate function. Okay, so I'm going to try 1.5 first, which is 3/2, right? Same sign on the zeros, opposite sign on the factors. So I'm going to divide. I'm going to do 3/2, 2, 5. Remember your placeholders here, okay? I don't need them for this, but that will kill you here.
Oh my God, we should do a decimal.
Oh my goodness, Shamik, stop whining. 3/2 times 2 is 3.
I don't know what that is. I ain't good with this.
3/2 times 8 is what? 12?
This is terrible.
Yeah, like this one.
That's -6. -6 times 3/2 is -9. -28, is that right? Oh Lord, I hope that comes out to be -42. Somebody do it.
Right.
It's not, it does.
Because you multiply it,
Nope, it doesn't.
you double it, and then subtract half of it.
Well, actually, if you cut it in half and times it by 3, so what's 14 times
Oh, yes,
3?
it does actually. I'm sorry.
Yeah.
I was doing 3 be over 4.
All right, no remainder. I know it's a good one. Yes, it's a good one.
It's a horrible.
Woo! All right.
Yippee!
Understand. What? Understand what this means. Hold on. Stopping again. All right. So I've got x minus 3 over 2. That's a factor because when you divide by a 0, it gives you the factor. Times 2x cubed
2x cubed
plus 8x squared
8x squared
minus 6x minus 28.
minus 28.
Now I need to factor this. Yes, I was going to say the very first thing that pops out to me is they are all divisible by 2. And anytime I have a GCF, I want to take it out. So, since multiplication is commutative, I'm going to just stick it in the front. And that leaves me with what? X cubed. Come on, guys, plus 4x squared minus, that wasn't a, minus 14.
And then we can.
No, Tanner was like, woo, but I.
We can slash it.
Can you slash it? Does it slash? No. Oh, tragedy. It doesn't slash.
Yes, it do.
No, it don't. If it, he said yes, it do. I don't know. I was trying. If you take x squared out of the first two, it'd leave you with x plus 4.
So can we stop?
Oh, no. Now that you know how to find a 0 when you don't have a 0, the same thing we did with the blue equation in the front, we are now going to do with the equation circled in yellow. We're going to PRZ that bad boy. Is this fun?
No.
PRZ.
I promise you this.
So.
Yesterday I was straight, but this is whack.
It's whack.
Oh, they're pollinating.
All right. Again, I would most definitely rely on my calculator, and I would say if I graph this function, please tell me at least one place where it crosses so I have a starting point, right? So that I could list out the PRZs. They would be 1, 2, 7, 14, right? One of those is bound to work. Which one? Has anybody graphed it yet? Know which one might work?
What's this? What's
I haven't
this
even written about
computer
it.
application? What is this application? What is it called?
Desmos.com.
DES.
MOS.
I forgot what
-2. You didn't learn it.
You haven't learned it yet because you came in late. You haven't forgotten.
-2.
-2. Thank you, Grant.
Wait, what is it called?
-2. Desmos.com. All right, watch what happens. Shh. All right, y'all pay attention. I'm almost done. If I divide by -2, 1, 4, -3, -14, I get 1, -2, 2, -4, -7, 14, no remainder.
Beautiful.
I told y'all this was a hard one, that this was a double PRZ and quadratic formula problem. Okay?
When did you do it?
At the beginning of the problem. Y'all, I'm telling you, y'all whine about this, but at the end of the day, this type of problem, you know how I told y'all your tests are cumulative and stuff? This one is easy for me to throw on a test and test you from most concepts of chapter 1 and some of chapter 2 also.
Do we have to put it in the quadratic?
Everybody is successful with this because it follows, it makes sense. Yes, Tanner, we are. I think. I can't remember.
No,
You think what?
no, you don't.
All right.
Because it gets
X plus 2,
factor, it crosses that.
x squared plus 2x minus 7. Tanner said, do we have to quadratic formula it?
Wait, what happens when you do what?
X plus 2 comes from this. Does it factor? Nothing multiplies to 7 but adds to 2.
Wait, where did you get, what?
Okay, so Grant graphed it for us, and he said it crossed the x-axis at -2.
Okay.
So that's why I used -2. Because I didn't want to just start trying random PRZs. I kind of wanted to know.
Get 2.
Okay, so this is the same, this is the same, right?
So that was
X cubed plus 4x squared minus 3x minus 14. all that breaks down into these two. What I divided by and what I got when I divided. So now Tanner's absolutely right. It's going to be a quadratic formula because as I look at this, I can set these first two pieces equal to 0 and I can solve those no problem.
You said all of it equals 0, so all of them no problem.
Yes, you can, Shani. 3/2. There is one answer.
What?
Ah, my brain's getting ahead
Are
of
you
me.
going to part the answer before you put it in the quadratic?
Well, I'm just showing you I'm setting each piece equal to 0 and solving. So now when I set this piece to 0, I go, uh-oh.
Add 7 to the side.
Well, it's a quadratic equal to 0, and it cannot be factored. I have no choice. Opposite b plus minus square root of b squared.
Oh, I don't like this formula.
Over 2a.
The only thing I like about
Okay,
it
I'm
is
confused. What does that say?
Where? 4 times 1 times negative 7. 4 times 1 times negative 7. So it's really going to be 4 plus 28,
4 plus 28.
which is 32.
How is it plus? Oh, how is it?
Then you can do
16.
in 2.
So 4 root 2 over 2. I'm out of room. I'm sorry. I hate it whenever people do this and go off. But it's going to be negative 1 plus or minus 2 root 2. Divide everything by that 2. Wow, that was a doozy, right? Wasn't it fun?
No!
I figured already.
Already? You just got in here.
Exactly.
Grant, you like this lesson?
Say no. You can say yes, Grant. Don't let them bully you.
You don't like this lesson.
Let